Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking about 2 days of upcoming severe weather in this day 2 and day 3 time period. There is also a day 4 risk, though we're not going to talk about that as much in this video just because I want to talk about these 2 days more. I don't think necessarily there was substantial risk. I haven't really had time to evaluate the day 4 risk, so I can't really speak too much on it, and that's why I just wanted to talk about the day 2 and day 3 risk. However, just taking a look at the Storm Prediction Center's probabilities, you can see on day 2 there is a 5% risk for tornadoes across portions of southern Kansas, southern and central Kansas, low end, but there's a risk of wind and hail, possibly some significant. The biggest uncertainty with this event is if storms initiate periods. Some models suggest a storm or two will develop, and those storms would be capable of all hazards. Some models say no storms are going to develop. As such, there would be no risk for severe weather if those storms don't fire. And we'll break down into why those models are different with that. But let's take a look at our HRRR first. We have to go to our 18Z run, our most recent run. And we can stay in the central United States. And we are going to take a look at what it shows on the reflectivity first. And if I recall correctly, this model won't really initiate anything during the day on Thursday. You can see this is our warm front. There could be some storms could organize along this warm front capable of mainly just hail. But when we look, okay, so this one storm, it tries to get going, but it really doesn't. Just to see what the environment is like, let's take a look at it out ahead of this line. You can see there is some pretty good current turning in the photograph, sufficient moisture, and there is a capping inversion, which is why there's uncertainty with storm coverage, but sufficient cape. Mostly everything else looks pretty favorable for tornadoes. So let's take a look at our capping inversion on the broader scale. And the reason this model always tries to initiate storms is because as we get into the evening on Thursday, you can see how this hole in the cap does develop. And it will move its way northeastward. And kind of right in this area on this model, in south central Kansas, there's a very weak, if any, cap left or convective inhibition. So to me, this area in here, really through about 1Z, and then it really starts to fill in. 1Z is about 8 o'clock Central Time for reference. It starts to fill in more, especially by 2Z, 10 o'clock. Severe risk would, at least for tornadoes, would be almost non-existent by that point, because storms would likely be, surface-based storms would likely start to become cut off by the convective inhibition. But you can see this period here, in the late afternoon and evening hours, where there's less of that convective inhibition, we could see storms fire in this environment because there's very little of that left. So even though there's not too much forcing, if there's also very little cap, then that does suggest a couple storms could develop in that environment. It's not quite a guarantee, but that could happen. That's why we saw on the reflectivity hinting at that storm development in the warm sector there. So now that we kind of talked a little bit about the capping inversion on the HRRR, let's just take a look at the rest of the ingredients. And we are going to take a look, and we're going to see by 23Z, let's take a look in that area where there was that gap in the convective inhibition. You're going to see there is some turning of the photograph. Pretty backed surface winds. A temperature dew point spread of about 20, which that can be sufficient for tornadoes. You can see how there's that weaker cap. And cape all above 2,000 suggests all hazards are possible. Supports all hazards, especially I do think very large hail with any supercell that does develop could be a risk, could be a hazard. Very large hail means over 2 inches in diameter. And the reason I say that is as we get into the evening, we can still see how, I believe that's the storm's developing right there, but let's take a look a little bit before it. We have a widespread 7 to 8 lapse rates, and perhaps up to 8.5 lapse rates where we could have these storms developing. So these steep lapse rates support a risk for large hail, and given how steep they are, And if storms do form, what would be a supercellular storm mode, that suggests very large hail would also be possible. Again, very large hail, 2+ inches. We are going to take a look at our bulk shear now. Let's see what else what we have for this. You can see the bulk shear is going to be sufficient for organized severe weather. We have greater than 40 knots, about 40 to 50 knots, which is going to be act to organize these supercell storms. If they can break through that cap, we're going to have sufficient shear to organize these storms into supercells, which is why when we overlap it with our 850 winds, we're going to see there will be a risk for tornadoes, because we can see, especially by 0Z, you can have a 35 to 40 knot low-level jet across portions of southern and central Kansas. And so if we get a supercell storm in this environment, which is not a guarantee, but if we do, it would be supportive of all hazards. Let's just see if we can take a sounding in this environment to see that. Okay, yes, so we have our turning of the hodograph here. Not the longest looping hodograph, but still that turning in the hodograph, combined with our nice moisture, mid-60 dew points. You can see the winds aloft. They don't really start turning this way and then go back the other way for the most part. It's a very clean rotation of the winds aloft, which also supports tornadoes. And you can see it is a little bit of convective inhibition, but that's a cap that if a storm was already ongoing in that environment, it could probably maintain itself through, I would think, at least. So there's our low-level shear. We're just going to take a quick look at our supercell composite. Actually, no, we'll take a look at energy helicity index instead. You can see right in this area, should continue to advance north, but there's a pretty ripe environment for supercell storms if they did fire. You can see here, still very well organized looping hodograph. All our Cape values are over 2,000, so again, this would support a risk for all hazards. Our critical angle is very good. You want a critical angle generally around 90 degrees to be best. 100, that's definitely sufficient. So we are now going to take a look at our NAM 3K, and what we are going to see is see how these storms fire on it. If I recall correctly, if I'm thinking of the proper model, and this model didn't really initiate stuff too much, I believe I would be... Okay, so again, you can see it tries to fire a storm, but it's generally not able to break through the cap. And that's like an overall theme we can be seeing with this. Is that the storms try to break through the cap, and they're not quite able to. So, we're just going to take a look and see how the NAM handles the capping inversion on this day. And we're going to look, and we're going to see in the day on Thursday, it really does not weaken that cap nearly as much, which is why that storm just kind of goes up and down. Compared to on the HRRR, it did last a little bit longer, even if it didn't have the strongest reflectivity return. So this difference in the capping inversion does cast a lot of uncertainty on whether storms will fire in this environment. But let's take a look at the other parameters quickly. If, let's just say, a storm does fire in this environment. You can see our Cape. It likes to have the instability axis a little farther west, but still overall, we're going to have sufficient instability. I do just realize that on the HRRR, we never took a look at our storm relative Felicity values, so we're just actually going to take a quick look at those really quickly. Hopefully I'm not forgetting anything else. And we can see how by 0Z it's generally across central Kansas where those best storm relative Felicity values are, but even into 1Z it does spread further south. Still the highest values are across central and northern Kansas, though northern Kansas there probably won't be a good chance of a surface-based storm compared to areas farther south. So I think that's why the Storm Prediction Center has highlighted a quarter that is roughly like this. Again, it's conditional upon getting a storm to form in that environment, but if one does, it has to have a lot of the ingredients there for tornadoes, wind, and hail. Okay, so on the NAM, I believe we showed the instability. Just for a quick refresher, we'll look over it again very quickly. because that was kind of not the most organized there on my part. You can see there's our instability axis, severe weather threats ended for that point though. So we took a look at our mixed layer cape, so now we're going to take a look at our lapse rates for this setup, and we're going to see how throughout the day they're all going to be supportive, very similar to the HRPR of all. Again, the lapse rates, the biggest thing you look for is large hail, then it's going to be very supportive of that. So we are now going to take a look at our wind shear and see how NAM3K handles our 850 jet. And we're going to see overall, by 0 to C, 30 to 40 knot low level jet. Very similar to the HRPR, so these models are seeming to be a good bit in agreement for the overall setup, but just not exactly sure on storm coverage. That's still being worked out. Again, our shear, I think the NAM seems to be a bit stronger on the bulk shear, but overall still 40 to 50 knots. That would be supportive of all hazards. And we're going to take a look at our storm relative Felicity values quick, and then we're going to move on to day 2. We're going to see how the NAM is more aggressive with the storm relative Felicity values. But you can see central and southern Kansas does show those values that support tornadoes. So you can see if we do get an isolated supercell to form in this environment, do you think the storm will be capable of damaging winds, very large hail, and some tornadoes as well? But we just don't really know if that surface-based storm is going to develop, which is rather frustrating trying to forecast this event. If I recall correctly, this model did try to initiate a supercell, so I just kind of wanted to show what that would look like quickly. Hopefully I have the model run correct. I think it was this one. Maybe I'm going crazy. Okay, so it was this model, the HRW WRFA RW model does fire this storm in southern Kansas. You can see it's a fairly long track storm. So if we were going to get a storm like this to develop, it would be capable of all hazards. But again, we're just not sure if we are going to get a storm like that to develop. I just wanted to try and show that quickly, to show that yes, a mature storm could evolve in this environment. We're now going to take a look at our day 3 risk, and we're going to look at our NAM3K for this one. Go back to our 18Z, and hopefully this is moving on central Kansas or central United States, including Kansas. Does work out for this. We're going to play this through, and I think what the NAM tries to do is develop more of an overnight severe threat, though there is a risk of daytime initiation as well that this model doesn't particularly show, but it is still possible. Well, it does show it a little bit here. But this is 6 o'clock. You can see these storms try to form across here in perhaps eastern Colorado, western Kansas, perhaps down into central or the western Texas panhandle as well. Just take a look and see what we're dealing with down here. Could be supportive. Some damaging winds, hail, and perhaps a tornado as well. But the main threat that the NAM tries to do is overnight with this big line of storms that develops. And it doesn't show it on this model run that regular NAM shows it. This line continues farther east, maybe to an area around here, roughly, and then it will begin to weaken some. So we're going to take a sounding here ahead of this line. And we're going to see that there's a bit of curving in this photograph. This generally would support, given the more linear mode, probably most of the damaging wind and tornado threat. However, still, given the moderate to strong instability and sufficient lapse rates, we could still see some severe hail in this linear mode. We are also going to take a look at the instability now that we saw how that mostly played out. And we're going to see as we get into the day on Friday, our instability axis is going to expand pretty rapidly westward. We can see by 0Z these storms developing along it. So let's take a sounding east, just used to those. And to me, these storms, based off of this particular sounding, as well as the overall moisture, which I think I'll show you here in a second based off this sounding, perhaps this initial mode, if it is this far west, if it's areas farther east, it will be in deeper moisture. But for this further west initiation point, there's not too much moisture with it, so that would make me think that would probably be mostly a hail threat with those storms. But if we do get further east initiation during the daytime, then a tornado threat would be more likely if that were to occur. So I said I was going to show you the moisture. Let's just take a look at it on the NAM 3K. 0Z. So you can see how this area here, there's not as much moisture, but if we were to get storms to initiate an environment like this, which is possible, it's not guaranteed, but it is possible, then if we have low to mid 60s dew points, so just take a sounding here, because why not, over upper 70s, that's going to give a favorable temperature dew point spread, though in this right here it appears this atmosphere still has some convective innovation, which is why storms are not developing there. Let's take a look at our shear now. And overall, it's going to be sufficient during the daytime hours. I mean, this is more than sufficient. We have a 40 to 45 knot low level jet, rapidly increasing after 0Z to over 50 knots. So this is why I think with that line of storms, that does develop overnight. We can still have embedded tornadoes within that line because our low level shear is going to be quite strong. Let's take a look at this at 3Z here. You can see our big curving hodograph, still a moderate amount of instability. So with those factors, that suggests tornadoes and damaging winds would still be possible, if not likely, if that 1 year mode evolves. We're going to take a look at our bulk shear quickly, and then before we wrap this video up, we're also going to take a look at our euro. And as we look at our bulk shear, getting into the afternoon and evening hours, we can see it's not that great, but as we across areas farther east, but across the slight risk area, we can, or the western half of the slight risk area, I should say, this low level shear does begin to increase 40 to 50 knots, and that supports most of that hail risk, just given the fact that the moisture return isn't as great. But this bulk shear will spread, well, actually it won't spread much eastward, so it looks like the overnight is probably going to be driven by the Cape and Shear here. You can look, see that that's our cold front here. Here's our line. You can see that there's still sufficient shear, but looks like the low level shear is going to be the driving factor for that severe weather event within that line, as well as the instability. We're going to take a quick look at this on the euro, just because the euro does show a further east initiation ahead of that big overnight line. There's some, take a look. You can see how storms are trying to initiate here. Maybe storms bubbling, maybe a supercell, and then storms evolve into a line of storms, and maybe a supercell further south. Just see what the environment would look like, where these storms are organizing here. And this model shows a much less capped atmosphere. There's very little capping inversion. That's why those daytime thunderstorms do form. Still, the moisture on the euro isn't the greatest, even areas further east, so that would tend to make me think more just a damaging wind and hail risk, not as much of a tornado risk with that, because a temperature dew point of 27 is just too much in that particular sounding. Perhaps a little bit further east. Let's just check what this says now. And now, it says there's no hazard with that. I would still think that even an elevated thunderstorm would still have a chance at hail, even if storms weren't surface-based in the sounding, based off of the lapse rate. So I think that plausible hazard to know is a little misleading with that. We could still see some damaging winds and hail with that. And then it still does show that squall line into the overnight hours, and we can just see how it advances eastward, and it eventually reorganizes. And this is our day 4 threat, though. Again, I really won't be going into that much. Hopefully I will. If I'm able to get a video out tomorrow, I will be able to, but I have work as well, so I have a very narrow window where I'm able to get it out, so hopefully I can. You can see, so that's what our Euro shows on the precipitation. And we're just going to take an overall look at our CAPE and other basic parameters very quickly. You can see how it just really does not have that western mode whatsoever. I bet if we were to check it, it probably has the dry line further east. Yeah, so by 21Z, this is our dry line way further east, where our NAM, here let's check it quickly, but just based off the instability, had to happen much further west. Yeah, our dry line's out here on the NAM, so that just goes to show the model spread even once this event is only 2 days away. But I do think I think the big takeaway from this event is that there's going to be that overnight squall line that will be approaching areas across this region. So generally, probably western Nebraska and Kansas into portions of central Nebraska and Kansas probably have the greatest risks for that overnight line of storms, and then the areas further east have a more uncertain risk, but a risk that is still there for those damaging storms, possible if they are able to initiate. Just take a quick look at our bulk shear, see how the Euro handles it. Still generally pretty weak bulk shear during the daytime hours. The overnight mode, it does increase. It's trying to increase a little bit, but it's still not too great. And we're just going to take out a CAPE hodograph spread quickly. You can see there is still some of those turning in the hodographs with that nighttime squall line. So that does still support a tornado threat even into the overnight hours, which will be something to watch, because this is 6Z is 1 a.m. Central Time. So if you have a tornado that's going on in the overnight hours, that could cause an issue if this severe weather threat does continue into the overnight hours, like most models are suggesting right now. I do think that is it. I will hopefully be able to upload tomorrow and give you another update on this event, as well as the day 4 risk, which I didn't really go into much detail, so hopefully I'm able to cover that, and I will see you next time. Bye.